Welcome to the presentation on exponents. If I were to ask you let me make sure this pen is the right width. If I were to ask you what 2 times 3 is, well, I think at this point this should be pretty easy for you. That's the same thing as 2 plus 2 plus 2, which equals 6. And you didn't have to do this. You all know that 2 times 3 is equal to 6. So what we're going to do now is we're going to learn exponents, which are the same thing that multiplication is to addition. Exponents are to multiplication, and I'll explain that in a second. I know that probably confused you. If I were to say what 2 to the third power is, instead of 2 plus 2 plus 2, this is equal to 2 times 2 times 2, which equals 8. Or if I were to say 3 to the second power, that is equal to 3 times 3. And remember, 3 times 2 would be 3 plus 3. And so this first 3 times 3, this equals 9, and 3 plus 3 equals 6. And the reason why I'm doing this is because there's always this temptation when you first learn exponents is to multiply. When I first learned it and I saw 3 to the second power or 3 squared, I'd always be like, oh, that's 6. But you always remember, no, that's 3 times 3, which equals 9. Let's do some more problems. If I were to tell you negative 4 squared, well, once again, that's the same thing as negative 4 times negative 4. Well, we learned from the multiplying negative numbers that a negative times a negative is a positive, and then it's 4 times 4. Well, this equals positive 16. You don't have to write the positive. I'm just doing that for emphasis. If I were to ask you what negative 4 to the third power is, well, that equals negative 4 times negative 4 times negative 4. Well, we know already that negative 4 times negative 4, that this equals 16, positive 16, and then we multiply that times negative 4. And then that equals minus 64. So something very interesting here to observe. When I took a negative number, we call this the base, when the base is negative, in the case of negative 4, and I raise it to an even power, I got a positive number, right? Negative 4 to an even power was positive 16. And when I took a negative number to an odd power, to 3, I got a negative number. And that makes sense because every time you multiply by a negative number again, it switches signs. I'll show you I guess you could call it the simplest example. Negative 1 to the 1 power is equal to negative 1, right? Because that's just negative 1 times itself one time. And if I said negative 1 squared, well, that's negative 1 times negative 1. Well, that equals positive 1. But then if I said negative 1 to the third power, well, once again, that's negative 1 times negative 1 times negative 1. Well, now this equals negative 1 times negative 1 is positive 1 times negative 1 equals negative 1 again. And so I could tell you what negative 1 to the 51st power is. Because 51 is odd, we know that that is equal to negative 1. If it was a 50, then it would be a positive 1. Hope I didn't confuse you too much. Let's do a couple more problems. If I asked you what 5 to the third power is, well, that's equivalent to 5 times 5 times 5, which equals 125. Similarly, if I were to ask you what negative 5 to the third power is, that would be negative 5 times negative 5 times negative 5, which would be negative 125. Now, one principle of exponents that might not seem completely intuitive to you at first is when I raise something to the 0 power. So let's say I had 2 to the 0 power. It turns out that anything to the 0th power is equal to 1. So 2 to the 0 power is 1. 3 to the 0 power is equal to 1. negative 900 to the 0 power is equal to 1. And let me see if I can give you a little bit of intuition of why that is actually the case. It's not erasing. Oh, there you go. So if I were to ask you, let's do 3 to the 4th power, that equals 3 times 3 times 3 times 3, which equals 81. 3 to the 3rd power is equal to 27, just 3 times 3 times 3. 3 to the 2nd power is equal to 9. 3 to the 1st power is equal to 3. And now we're going to say, what's 3 to the 0th power? Well, we already know, I already told you the rule, anything to the 0th power is equal to 1, but this would hopefully give you some intuition. When we went from the 4th power to the 3rd power, we divided by 3, right? 81 divided by 3 is 27. When we went from the 3rd power to the 2nd power, we divided by 3. When we went from the 2nd power, from 9 to 3, we divided by 3. So it kind of makes logical sense that when we go from the 1st power to the 0th power, we'll just divide by 3 again. So 3 divided by 3 is 1. Hopefully that gives you a little bit of an intuitive sense. You might want to replay that and think about why that is. And there's actually other aspects of exponents that why this would also make sense, why something to the 0th power is equal to 1. But let's just do some more problems in the time we have. I don't want to get you too confused. So if I were to ask you 7 squared, well, that's 7 times 7. That's 49. 49. If I asked you negative 6 to the 3rd power, parentheses around here, so you know it's the whole negative 6 to the 3rd power, that equals negative 6 times negative 6 times negative 6. Negative 6 times negative 6 is positive 36 times negative 6, and that equals what? It's 180 and 36. That's minus 216 if my mental math is correct. You could have actually multiplied it out. But if we did, I think you're getting the point at this point. If we said, oh, and another thing, if I told you 0 to the 100th power, well, that's pretty easy. That's 0 times itself 100 times, which is still equal to 0. If I were to ask you 1 to the 1000th power, well, that's just equal to 1, right? You can multiply 1 by itself as many times as you want, and you're still going to get 1. And remember, if I had negative 1 to the 1000th power, well, this is an even exponent, so you're still going to get 1. If it was negative 1 to the 1001, then it would be negative 1. I think you remember why this is, because when you multiply a negative times itself an even number of times, the negatives cancel out, and then if you multiply it by a negative one more time, it becomes a negative number again. But let's just do some normal problems. I just want to make sure you get the basics of exponents down. If I were to tell you, let me think of a good one, 8 squared, that equals 8 times 8, which equals 64. If I were to tell you 25 squared, well, that's 25 times 25, which equals 625. Powers of 2 are always very interesting. It's especially interesting if you one day go into computer science. So 2 to the 4th power, that's 2 times 2 times 2 times 2. So 2 times 2 is 4, and 2 times 2 is 4. So it's equals 16. And I did something very interesting here, kind of on purpose. Notice that 2 to the 4th is equal to 4 times 4, right? Because we did 4 times 4 here. And I'm going to detail this more later on, but I want to think about what that means. Because 4 itself is the same thing as 2 squared. So we learned just real fast that 2 to the 4th is the same thing as 2 squared times 2 squared. So I'll let you sit and think about that. But other than that, I think you have the general idea of how basic exponents work. And I think you're ready to try the Level 1 exponent module. Have fun.